Hello, everyone. My name is Mr. Zabron Ernest, a teacher at Alimuntazili Islamic Seminary, Girls Wing. Welcome back to where we ended. Yesterday, we talked about bearing, and I tried to define what does bearing mean. And I said that bearing is nothing but an angle. And we tried to see different many questions on how to calculate the bearing of a given point from another point. Okay, now today we'll be continuing with making scary drawings. It's a subtopic under bearing. So it's just like a quick tutorial on how to make scary drawings and how to answer questions related to scary drawings. So here we go. The first thing you have to know is what does scale mean? If someone says, what is the meaning of scale? So we say scale is the relationship between the distance on a map with respect to the distance on the ground. When I say distance on the ground, I mean the actual distance or the actual length of an object in real life. All right, so putting it in practice, let's try to see some few questions which talk about scale. We have this question here, for example. This question says that a map is a scale of 1:50,000, okay? A map has a scale. So what does a scale mean? I said that scale is the relationship, or scale is the ratio between the distance on a map to or over the distance on the ground. When I say the distance on a ground, I mean actual distance or a real distance. So this is actual distance or ground distance. That is all about scale. Okay, now let us see this question. A map has a scale of 1:50,000. Now on the map, a football path or a footpath is 12 centimeters long. What is the length in kilometers of the footpath in real life? So we have two things here. We are given the scale, and remember what I said? I said that a scale is the distance on a map over the distance on the ground. Okay? Now this scale is given as 1:50,000. Now the question is, on the map, a footpath is 12 centimeters long. So this distance you see here, 12 centimeters long, is the distance of the footpath on a map. Now, how do we find the length? And that length should be in kilometers of the footpath in real life. That means work out the actual length of the footpath. That means the distance on the ground. So what we're gonna do, we're gonna write that ratio, 1:50,000 as a fraction. So you write here, the scale is 1:50,000. So you write 1/50,000. This ratio will be equal to the distance on the map, which you read which you have to read the question. And this question says, on the map, a footpath is 12 centimeters long. So the distance on a map is 12 centimeters over the distance on the ground. And that's the question. What is the length in kilometers of the footpath in real life? So the question is asking for the actual length, meaning the distance on the ground. So here, the distance on the ground, that is the question. So the distance is unknown. So you write any letter. You can put A, you can put X, you can put D, you can put any letter. Now from here, you cross multiply. This will be equal to 1 times D equals to 12 times 50,000. Okay. Now remember, this 12 is in centimeter. The data you have is in centimeters. So this will be 1 times D equals to 12 centimeters times 50,000. Did you see that? So 1 times D is D. That means the distance on the ground or the actual length of the footpath. This will be equal to 12 centimeters multiplied by 50. Now 12 times 5, this is 60. 12 times 5 is 60. And then you keep these 1, 2, 3 zeros. 1, 2, 3, 4 zeros next to each other like this. So we have 1, 2, 1, 2, and then 1, 2. So the answer will be 600,000 centimeters. Okay. Now, if you go back to the question is saying, find the length. What is the length of this footpath in kilometers, not in centimeters? So then you have to go back to King Henry Daughter and see in 1 kilometer how many centimeters are there. So you are supposed to find, you are supposed to convert this answer here, 600,000 centimeters, into kilometers. Now, how do we do that? We go back to King Henry Daughter and then you try to search for 1 kilometer equals to how many centimeters. So in 1 kilometer, we have 100,000. We have 100,000 centimeters. Now, how about 600,000 centimeter? That will be equal to how many kilometers? So you cross multiply like so, and then you'll be getting 600,000 times 1. The answer you get, you divide by 100,000. So this will be 600 times 1. 600,000 times 1 is 600,000. Okay. Then you need to divide by 100,000. Okay. Now all these zeros will be cancelled, and the answer will be equal to 6 over 1. But what is 6 over 1? That will be equal to 6. Okay. Now, what is the actual length? So let us try to go back to the question. What is the length in kilometers of the footpath in real life? That means what is the actual length of this footpath, whose length is 12 centimeters long on the map. So the actual length of the footpath in kilometers will be equal to 60 kilometers. Now, how do we conclude that? We simply write the actual length. So you simply write the actual length, of the footpath the actual length of the footpath in kilometers is 60 kilometers. This is the actual length of the footpath. All right. So now I hope you have understood what does a scale mean and how do we use the given scale to answer the given questions. Okay. So go ahead trying some few questions. I'm gonna send a PDF file so that you can download and then take a lot of practice on how to on how to calculate scale questions. But otherwise, let us proceed to question number 2. Now, question number 2. In real life, a road is 12 kilometers long. Okay. In real life, a road is 24 kilometers long. What is the length in centimeters of the road on the map? Now, which map are they talking about? They are talking about the same previous map, whose scale is 1:50,000. So we go back to this scale. They are still talking about the same scale because this is Roman 1 and the other one is Roman 2. So the same question. Let me try to copy this scale of the map. Okay, so copy that, put it somewhere here so that we should not lose focus. Okay, try to put it here. There we go. So a map has a scale of 1:50,000. In real life, a road is 24 kilometers long. You know what it means? It means that here, what they say in real life, it means the actual length of this road, the actual length of the road is 24 kilometers long. It's the actual length. This is the distance on the ground. Okay, now what is the question? What is the length in centimeters of the road on the map? So what you are supposed to do is to find the length of the road on the map. Now, remember, to answer this question, we have to go back to the scale. A map has a scale of 1:50,000. But what does a map mean? We said by definition, scale of a map is a ratio between distance on a map over distance on the ground. Distance on the ground. This is the formula by default. So scale of any map equals to distance on a map over distance on the ground. But what does this distance on the ground in other words mean? Distance on the ground, like as I said earlier, is the actual length of an object. Now, in this case, they are talking about the road. So here, the distance on the ground will be the actual length of this road. Okay, now in real life, a road is 24 kilometers long. Guess what? This 24 kilometers long is the distance on the ground. Now the question is, what is the length in centimeters of the road on the map? Okay, so you go back to the scale, formula, which says scale. The given scale is 1:50,000, which you have to write as a fraction. So it will be 1 as a fraction, it will be 1/50,000. Okay, now this scale, which is given here, is equals to the distance on the map, which we don't know. See this question, what is the length in centimeters of the road on the map? So this time we don't know the distance on a map. So distance on a map, you keep a letter, say M. The distance on the ground is the actual distance or the length of the road in your life, which is 24 kilometers. Okay, so this is distance on the ground is 24 kilometers. Okay, so when you cross multiply here, what do you think you're gonna get? Okay, so this will be 50,000 times M will be 50,000 M. That will be equal to 1 times 24. But remember, that is kilometer. So the answer we're gonna get here will be in kilometer. But the question says we have to work out what is the length in centimeters. So the answer we get over here will not be the final answer. We need to change that answer, which will be in kilometers, into centimeters. So there we go. 50,000 times M is 50,000 M. So you have 50,000 M equals to 1 times 24 is 24. But remember to write kilometer. To find the value of M, you need to divide by 50,000. You need to divide by 50,000. You need to divide by 50,000. Okay. So what is the value of M? So the value of M will be equal to 24 over 50,000. But remember, this will be kilometer. Now the question is not saying leave your answer in kilometers. The question is saying what is the length in centimeters? So we need to find that length in centimeters. So how do? We start afresh. You go back to King Henry Daughter, and then you find out 1 kilometer equals to how many centimeters? So 1 kilometer equals to 100,000 centimeters. Now, how about this fraction which you got and which is in kilometer? So you're gonna write 24 over 50,000. This will be equal to how many centimeters? So you need to cross multiply. Okay, how do we cross multiply? It will be this fraction here times 100,000. The answer you get, you divide by 1. This will be 24 over 50,000. 24 over 50,000 times 100,000. Okay, then the answer you get from there, you need to divide by 1. Let me repeat. How do we cross multiply here? This fraction will be multiplied by 100,000. This fraction multiplies 100,000. The answer you get, you divide by 1. Okay, and remember, the answer you get from here will now be in centimeters. Will now be in centimeters. Now let us proceed. How do you multiply this? Take advantage of these zeros. We have 1, 2, 3, 4. So we have 1, 2, 3, 4. So cancel this and cancel this. 1, 2, 3, 4. Can you see that? And then you do by 5, 1, by 5, 2. So the answer will be 24 times 2. The answer you get, you divide it by 1. And this will be equal to 48 centimeters, because 24 times 2 will be 48 centimeters. Now, how do we conclude this? We conclude by saying that if in real life a road is 24 kilometers long, what is the length in centimeters of the road on the map? So we say 24 kilometers. So we say the road of 24 kilometers will be equal to 48 centimeters on the map. Okay, on the map. Right? I hope that is clear. Then let me move to another question. But by now you can pause this video and try to take the short notes on how to answer this question. Right? Otherwise, let us move on to the next question on scale drawing. Right? So the next question is this one here. This question here. This is the next question. Now, the question says, a ship leaves harbor and sails 120 kilometers on a bearing of 85 degrees. Okay, now we are back to the discussion which we did yesterday. Okay, so a ship leaves harbor and sails 120 kilometers on a bearing of 85 degrees. Okay, it continues sailing 90 kilometers on a bearing of 135. Now make a scale drawing of the ship journey. Make a scale drawing of the ship's journey. Use a scale of 1 centimeter on a ruler to represent 10 kilometers. You are given a scale here that on a ruler you have 1 centimeter. Now 1 centimeter on a ruler or 1 centimeter on a map. When I say on a map, I mean on a scale drawing. So when I say 1 centimeter, take the 1 centimeter as the other one which you have on the ruler. So 1 centimeter represents 10 kilometers. Now, before you start drawing, you have to before you start drawing, you have to do some small conversions, which are: 1, you need to convert 120 kilometers into centimeters, because without doing so, you can't be able to draw this ship's journey. So you have to do small conversions, which include changing 120 kilometers into centimeters. And how do we change 120 kilometers into centimeters? We use this scale here. Now, so step number 1, let us change 120 kilometers into centimeters. So we use this scale that if 1 centimeter on a ruler will represent 10 kilometers. Now, this 120 kilometers will be represented by how many centimeters on a ruler? So it's just a direct question which needs cross multiplication, and this will be 120 times 1, the answer you get, divided by 10. So this will be 120 multiplied by 1, the answer you get, divided by 10. So you can solve this quickly and end up getting 12 centimeters. Now, what does it mean? It means that to measure a distance of 120 kilometers, you need only to measure 12 centimeters on a ruler. I hope that is clear. So that is step number 1, small conversions. Another conversion is to convert 90 kilometers into centimeters. So I think you can pause this video and try to convert 90 kilometers using the scale given into centimeters. Otherwise, let us proceed. Okay. Now, how do we do that? We go back to the scale again, convert 90 kilometers into centimeters according to the given scale. The given scale is that 1 centimeter represents, meaning equals to 10 kilometers. That is the scale given. Now, how about 90 kilometers? How about 90 kilometers? How many centimeters on the ruler will be representing 90 kilometers? So you need to cross multiply. This will be equal to 90 times 1, which is 90. The answer you get, divided by 10, and this will equal 90 centimeters. Now, do you know what it means? It means that a journey of 90 kilometers, it means that a journey of 90 kilometers will equal only 9 centimeters. So we're gonna use this distance, which is in centimeter, and also this distance, which is in centimeter, to draw the ship's journey. Make a scale drawing of the ship's journey. Okay. Now, after these small conversions, then let me go to draw the ship's journey. All right. So let me try to remove all these. Let me try to remove all these so that you can get space for us to draw the ship's journey. All right. Now, but as for now, you can pause the video and check the calculations of all these conversions, but I think these conversions to you will be easy, right? Now, let us try to remove all this, and then draw the ship's journey. Okay, now how do we do this? We already know that according to the scale, we already know that for a distance of 120 kilometers, we will only draw 12 centimeters, okay? And for a distance of 90 kilometers, we'll be drawing only 9 centimeters according to this scale, okay? Now let me start measuring. A ship leaves harbor. So let us assume that harbor is somewhere here. So you mark harbor using a point or a dot. You can't draw harbor by itself because harbor looks to be complicated. So you just represent harbor by using a simple dot like this. So that is your harbor, and then you label capital letter H to mean harbor. So the ship is there. Now the ship is sailing at a bearing of 85 degrees. Now, what do we do to measure this bearing? The first thing you have to do is draw your north direction. You have to draw your north direction at this point here. Draw the north direction so that you can now be in position of measuring the bearing of 85 degrees. Okay. Now, after drawing this north direction, then from this north, you need to measure an angle of 85 degrees. You need to measure an angle of 85 degrees. Okay. Now, how do we do that? Stay tuned and watch me what I'm gonna do to measure the bearing of 85 degrees from this north direction. This is your north direction, and it will be our reference point to measure the bearing of 85 degrees. So this is north direction. So what I'm gonna do is take a protector and put it over this north direction. So I take my protector over here. Take the protector over here and then put this protector. Can you see this? Can you see this protector here? Put the center of this protector. Put the center of the protector somewhere there. At that point, can you see that? Put the center of the protector somewhere here. And then rotate your protector in such a way that the north direction should read 0. Should read 0. And the numbers which I'm referring to are these numbers which are outside the protector. These are the numbers which I will be reading to measure a bearing of 85 degrees. Okay. Now, 85 degrees. How do we read 85 degrees from the protector? So this is my reference point. You see that? That is my reference point. North is always your reference point, and then you read these numbers outside to measure a bearing of 85 degrees. So this is 0, that is 10. I'm reading the outside numbers, don't confuse. So that is 0, this is 10, 20, 30, go ahead until you reach 85. So 40, 50, 60, 70, 80. So 85 is somewhere there. You see that? Now at that point where 85 is, you put a dot. You put a dot to show that that is a bearing of 85 degrees. So keep a dot like that. After keeping a dot, and then remove your protector. The dot will still be there. Now, how long? What is the length from this point representing harbor to where the ship is? The ship has moved from this point H, is no more available on the H, but then it is available on this point here. So what you're gonna do is to connect this point here to this point. But how far should you go? A ship leaves harbor and sails 120 kilometers on a bearing of 85. So you need to take a ruler. You need to take a ruler. Put your ruler somewhere here, and then measure 120 kilometers. Now on the ruler, you can't measure 120 kilometers. That is when we need a scale, and the scale gives us 12 centimeters. So we're gonna measure from this point. We're gonna measure from this point to this direction. We're gonna measure. Let me try adjust that. Okay. So you're gonna measure from this point here, put the zero mark of the ruler should be somewhere there, and then turn around and read 12 centimeters, read 12 centimeters in this direction, and then draw a line. Okay, so I'm gonna do it for you. Read from the ruler, read from the ruler, you have to read from here in this direction of 85 degrees. So measure, 1 minute. So measure from here a distance of 12. So I'll start from here all the way until that point there. See that? So now the ship is at this point here. The ship is at this point here. A bearing of 85 degrees and a distance of 12 centimeters. Okay, so I hope that is clear. And we can do some small labeling that this is a bearing. So do small labeling that this is a bearing. We try to label using a small mark that this is a bearing here. This is a bearing of 0.85 degrees. And the distance from here to here is 120 kilometers, but we don't write 120 kilometers, we write 12 centimeters. Okay, so now the ship was moved from this point. It is now here at this point. All right, so this is the ship, and then we continue again. It then sails 90 kilometers on a bearing of 135 degrees. So from where we ended, we need again to measure a bearing of 135. We need again to measure a bearing of 135 from where we ended. So go ahead taking a protector, but before that, you need to draw a north direction. Before that, you need to draw a north direction. But at this point, the north direction will not be drawn here, will now be drawn here, the new location where the ship is. The ship now is somewhere here. So at that point here is where we draw the north direction. Okay, so we draw the north direction somewhere there. And then at that point is where we measure. At this point is where we measure a bearing of 135. Is where we measure a bearing of 135. So how do we do that? Take your protector. Take your protector, and this is your protector. And then set your protector somewhere here. Set your protector somewhere here, and this north direction should read 0 again, and then this north direction should read 0. The north direction should read 0. The north direction should read 0. Can you see that? Now what are we supposed to do? We are supposed to measure the bearing of 135 from here. So 135. Please read the outside numbers, those outside numbers. So 135. So there we go. That is 0, 10, 20, 30, 40, 50. Okay, 50. Keep going until you hit. This is 100. This is 110. Until you hit 135. That is 130. 135 will be somewhere there. Go ahead putting a label or a dot where 130 is ending. So you have to keep a label to show where 135 ends. All right. So let me keep a label for you. And here we go. This is a point where 135 is ending. Okay. So after that, you take out the protector like that. Take out the protector, And then you need to measure using a ruler. You need to measure using a ruler. Turn your ruler like this, turn it like this. In this direction, measure a distance of, or measure a length of how many kilometers? 90 kilometers. But on a ruler, you can't locate 90 kilometers. But according to the scale, we got 90 kilometers equals to 9 centimeters. So in this direction, you're gonna read only 9 centimeters, okay? 9 centimeters. All right, so the first one was 12. Let me try to cross-check and see if what we read is correct. Yes, that was 12. Congratulations, that was 12. But now in this direction, we'll be reading only a distance of 9 centimeters. How did I know? This is 90 kilometers, but there will be only 9 centimeters according to the scale. So in that direction, measure 9 centimeters. Okay, so take your pencil, draw that. Draw a line as follows. Okay, you need to draw a line from here, from this point up to where 9 centimeters is. 9 centimeters somewhere there. So stop here. You see your 9 centimeters? Stop. You have to stop there. Okay, that is more than 9. So you need to adjust in such a way that you'll be fitting your line like that. See? So you need to adjust until you get 9 centimeters. Now using my ruler, that is 9 centimeters. Okay, so that is 9 centimeters. And how much was this? This was 12. So this was 12. This was 12. Can you see that? That is 12. And can you also see that? Can you also see that? Can you also see that here is 9 centimeters? Can you see that? All right. So you can adjust your ruler in such a way that the measurements are accurate. The measurement should be accurate. Okay. Now, once you do that, this point here, can you see this point here? This point, let me try to show you. The point over here, this point here is now the new location of the ship, because they are saying a ship leaves harbor and sails a distance of 120 kilometers on a bearing of 85. I've done that. It then sails 90 kilometers on a bearing of 135. So the ship is no more here. A ship is now somewhere here. There we go. That is your ship. Can you see that? I hope yes. Now, what are we going to do next? What we're going to do next is to label this, that this part is 135. This part here is 135 bearing. So you have to label that this part here is 135 degrees. Okay, so this is what we call. Is there any other journey the ship has sailed? No, because they said a ship leaves harbor and sails 120 kilometers on a bearing of 0.85. It is done here. It is done. It then sails 90 kilometers on a bearing of 135. It's done there. Okay, make a scale drawing of the ship's journey. This, the sketch which I have done here. Can you see this sketch? Can you see this sketch over here? This sketch is what is supposed to be. So this is what we call ship's journey. This is what we call ship's journey according to this question. According to this question. All right. Now, what else? Let's see if we have something else. Let's see if we have got something. No, the question in Roman 1 is to make a scale drawing of the ship's journey. Use a scale of 1 centimeter to 10 kilometers. That is done. So this is what we call a scale drawing. So you can try to pause this video and see if you can draw something like this. Otherwise, it looks neat like this. Okay. So let us move on. We have Roman 2. Roman 2 is this one. Roman 2 is this one. How far and on what bearing must the ship now sail to return to the harbor? Oh, the ship has to sail from here. The ship has to again go back from here, back to the harbor. The ship has to sail. How far and on what bearing must the ship now sail to return to the harbor? It has to go back to the harbor. How do we do that? How far means distance. Oh, we are supposed to calculate the distance. How far means distance. Okay. How far means distance. What bearing means angle. Now, how far means how far and on what bearing must the ship now sail to return to the harbor? You know what you're gonna do? You need to find the distance. You need to find the distance from where the ship is back to the harbor. You see that? So what you're supposed to do in the other question, in other words, this question may ask like this: how far and on what bearing must the ship now sail to return to the harbor? In other words, this question can ask us, what is the bearing? What is the bearing of the harbor? What is the bearing of the harbor? From where the ship is, from the ship. Now, what are we supposed to do if you get a question like this? What is the bearing of the harbor? What is the bearing of the harbor? What is the bearing of the harbor from the ship? Now the ship is here. The ship is here. This is where the ship is. Now, what is the bearing of this harbor? What is the bearing of this harbor from the ship? You know what you're supposed to do? We have few steps to follow. Step number 1, draw the north direction. Step number 1, draw the north direction at the ship. Draw the north direction. Okay. Step number 1 is to draw the north direction. Step number 2 is to take your ruler. Connect where the ship is to where the harbor is. You see that? Now, how far? I should repeat that. How far is the harbor? How far and on what bearing must the ship now sail to return to the harbor? How far? Let me start answering that. How far? How much distance should the ship sail to return to the harbor? What you are supposed to do now is to take your ruler and measure this distance. Measure this distance from here to here. Measure that distance. Okay? Right? Measure that distance. And I hope your ruler is long enough, but with my ruler, I have unlimited length. I can extend my ruler like that. So I need to measure that distance. But remember, as you transfer your notes from here, from the video to your counter book, of course, you may lose some scale. So in that case, bear with me. The answers I'm getting can slightly differ with your answers. That is definitely because as you transfer the notes from my video to the counter book, you may end up losing the scale. Okay, so how far? Measure this length from that point to this point here. Now, according to my tools, that to me is 14. Can you see? This is 14, 14.5, 14.6. Okay, so that is 14.6. So this, according to my tools here, is 14.6. So you'll be writing here 14.6 centimeters. But then you have to convert this 14.6 centimeters into kilometer, because the question is how far should. The question is how far and on what bearing. Bearing I'm going to show you how far the ship now has to sail to return to the harbor. So that distance which you have measured using a ruler should be converted back to kilometer. How do we do that? We use the scale. We use the scale. How do we use the scale? We say that according to the scale, 1 centimeter equals to 10 kilometers. Now, how about the 14.6 centimeters equals to how many kilometers? Simple question. 14.6 multiplied by 10. The answer you get divided by 1. So the answer will be 146 kilometers. So you are 14.6. Your 14.6 centimeters will be equivalent to 146 kilometers. I think now I have answered the question which says how far? 146 kilometers. So here, how far? Distance will be 146 kilometers according to my tools. You may be getting slightly different from here. Now, on what bearing? Now, can you try to pause this video and tell me which bearing are they talking about? The bearing which they're talking about, you can try to pause this video and try to tell me what do you think the bearing is under the question. Okay, but here, if you don't want to pause the video, then let us move on. But here you can try to predict which bearing do you think they're talking about. The bearing they're talking about is, like as I said, is the bearing of the harbor from the ship. The bearing of the harbor from the ship is this one here, from the ship. Is this angle all the way until there? Bam. That is the angle they're talking about. Now, how do we measure that angle? Yesterday I told you. How do we measure that bearing? By default, take advantage of this line. Extend this line vertically down. Can you see that? That makes 180. That makes 108. Can you see this? This portion here is now 180 degrees. So this by default is 180 degrees because that is the angle formed on a straight line. So what you're gonna do is now complete the calculation by measuring only this small angle. The answer you get, you add it to 180 degrees. The answer you get by measuring that small piece, add it to 180, that will be your final answer, all right? Now, how do we do that? Take your protractor, like that. Take a protractor. Okay, this is my protractor. Set it somewhere here. Set it somewhere there. You see that? Set it somewhere there. And then turn around your protractor. Turn around your protractor. So that the zero, can you see the zero of those outside numbers? Because we measure the bearing in a sense of clockwise direction. See that? Let me try to use my pointer. This is my pointer. Okay, so rotate your protractor in such a way that the zero mark of the outside numbers are set this way, and then come around and read. This is 0, 10, 20, keep going, 40 until you hit this line here. Can you see that? Bam. That is your angle you are looking for. And then read how much is that angle. This angle is 10, 20, 30 all the way. This is 100. This is 100 and what? 101, 2, 3, 4, 5. Okay. According to my tool, this will be 100, 101, 2, 3, 4, 5, 6. 106 degrees. So go ahead writing 106 degrees. So this will be 106 degrees. So this part here is 106 degrees. Okay. You can try to check properly. And then let me try to confirm if I'm correct. I may make mistakes because I'm a human being, right? So let me try to confirm that. Okay, that will be set properly. Okay, 110, 105. Yes, I'm correct, according to my tools. So now how do we combine 106 degrees and this 180? We add, and that will be your final answer. So here you write bearing is 106 degrees and add 180 degrees. What do you get as total? That will do some maths. That will be 6. That will be 6. That will be 8. That will be 286 degrees. That will be your bearing. Okay? So for today, let us stop here. Now, I told my students in my class today that after I finish the last part, which is on scale drawing, I'm gonna leave with them. I'm gonna give them some questions. Okay? But before that, you can pause this video, take the drawing. See that the drawing, this drawing is Roman 1, and Roman 1 was to draw a scale drawing. Roman 2 was how far and on what bearing must the ship now sail back to sail to return to the harbor. So all those you combine, you get a diagram like this. Okay, now my students, I promised my students that today, after finishing the last part on the bearing, I'm gonna give them questions. Okay, now the questions which you are supposed to do, this is a PDF. This is a PDF worksheet. Okay, this is a PDF worksheet. And these questions are the questions which we use to teach your elder brothers and elder sisters who were in Form 2 like you last academic year, when we had something like a lockdown of schools where students had to go home, and then we used to reach them through Zoom, and this is what we taught them. Okay, so I want now you people, and that is why you can see Form 2 worksheet week number 2. So you may be surprised why week number 2. No, this is the work that were given to your fellow students who are currently in Form 3, because they studied in Zoom. They studied online like you people. So once I close this video, I'm gonna send this PDF file. You need to do all these questions. You see question number 1. Print that. There are some people who said they're gonna print at home. I don't mind. So print this document and bring it to school tomorrow. Okay, and can you see, you're gonna do all these questions. They are there on the PDF file. PDF document. You see that? Yeah, all these are bearing questions and scale drawing. Okay, can you see all those? Can you see this? Okay, now try those questions. For those who can print at home, try those questions. Also, I have attached, now listen very well. Listen to me very well. All these questions on bearing, can you see that? Please, all these questions, as you print, can you see? I have also attached a revision paper on tessellations. Can you see that? A regular hexagon is drawn below. Can you now show how a hexagon tessellates? I've taught my students tessellations, and I hope many others have done that. Okay, so all these, my 2G3 students are expected to do all these revisions questions, okay? Now, how do we print? Listen to me. How do we print? Print only on one side. Print only on one side. My students knows why. We need to stick all these papers on our counter box and then do the questions, okay? So let us stop here. I'm gonna send this PDF file in the Microsoft team and then download. But there are few students who say that I may print for them from the school stationery and then they refund money. So either way is correct. All right. So let me stop here until next time. My name is Zebron Ernest, Ali Muntazir Islamic teacher. Bye bye for now. Stay safe. Bye.